All right, today we are looking at 7.4 for our notes. We're talking about something called zero product property. This is kind of our first section in which we're getting into something that's called factoring. We're looking at things that are factored. Looking up here in our definitions box for box 1, we have two different ways that we can write an equation. So this way that we are used to seeing it this chapter, what we've been kind of working towards this chapter, is called standard form. We know standard form for a polynomial is descending exponent order. So on this left side of my equation here, I've got x squared minus x minus 12. That is in standard form because my biggest exponent comes first. The smallest exponent is all the way to the right. So that's what we've been working towards. For the second half of the chapter that we're going to be picking up after spring break, we're looking at something called factoring, where we know that if we're talking about factors of a particular product, so like factors of 15 are 3, 5, 1, and 15. All four of those different things multiply to get 15. So those are my factors of 15. Now, in this case, we're looking at the polynomials that would multiply together to give me my standard form. So in this case, if I actually went through and FOILed or box multiplied x minus 4 times x plus 3, I would end up with x squared minus x minus 12. So they're two equivalent equations. It's just that one is in standard form and one is in factored form. Now, this factored form is way, way, way easier to work with when we're trying to solve an equation. So because we have two different x values, we're going to have two different answers, and that makes things a little bit more complicated. So what we have to use, like the thing that we need in order to be able to solve those equations, is something called zero product property, which I just shortened down to just ZPP. So ZPP, we're going to look at two different ways. I'll give you the kind of the English, the words definition of this, and then we'll look at what it looks like algebraic or what it means algebraically. So what zero product property tells me, what ZPP says, is that if a product equals 0, so if I have two or more things multiplied together and they are set equal to 0, if they equal 0, that means that then at least one of the factors must be 0. So that's the definition using our words. So if we have a product that equals 0, at least one of the factors must be 0. So what that looks like algebraically, if I have two things that multiply together, let's just say x times y, if that equals 0, well, the only way that I can have that be true is if either x is 0 or if y is 0. If I know they multiply together to be 0, one of them or both of them are 0. So the way that we'll use this is if we have two things or if we have multiple things that multiply to get 0, we're going to basically just set each of those different factors equal to 0. And that'll give us different options for what variables could be in order to make that a true equation. So it's actually going to look pretty similar to when we did absolute value equations. If you guys remember that way, way back in chapter 1, where we kind of split our equation off into two smaller equations. It's going to be the same general idea. So if we hop over here into box 2, which is some simple examples, we're given for number 1 that x minus 3 times x minus 9 equals 0. So the only way that that's going to be true is if either x minus 3 equaled 0, or if x minus 9 equals 0. So once we have those two equations established, once we have those two things set up, we're just going to solve each of them independently. So just like I did back in chapter 1 for absolute value equations, for this first one, I'm just going to add 3 on both sides to get my first option as positive 3. On my right parenthesis, I have to add 9 on both sides to get positive 9 as my other solution. And those are my two different options. Those are my two solutions. Now, either one of those will work because if we went through and checked our answer, if we went ahead and actually plugged either of those two into my equation, if we did, let's just check 3 first. If I plugged 3 in for x, I end up with 3 minus 3 times 3 minus 9 equals 0, which 3 minus 3 is 0, 3 minus 9 is negative 6, and 0 times negative 6 is 0, so that works. If I plugged in 9 minus 3 times 9 minus 9 equals 0, so I end up with 6 times 0, which of course is also 0. So we can see actually in this case, both of those are solutions. So it doesn't matter that we have more than one solution, it's still just our two solutions. It's still those two, either of those two x values would make my equation true, because it would give me one of my two parentheses as a 0, which is what I need. So another just simple example here. It doesn't matter if there's parentheses around it or not. This could have been written as just 2x times x minus 4 instead. So I'm still just going to do the same process. I'm still just splitting off whatever my factors are and setting them equal to 0. So 2x equals 0, and then x minus 4 equals 0. And I'm just going to solve each of those independently. I'm going to divide by 2. X equals 0, because 0 divided by anything is just 0. And then here I can add 4 on both sides, and we get x equals positive 4. So those are my two solutions. And again, you could check to make sure that you're going to get 0, but in this case, I'm good. I know that it's going to be true. The nice thing is that's pretty much it. The only thing that can get more difficult, or the only thing that's going to be a little bit more challenging, is that the individual parentheses are going to be more difficult to solve once you split it up. It's still going to be already factored for us in this section. It's still going to be separated out into different parentheses or different terms. So I'm still going to do the same setup. So here for number 3, 2y plus 7 has to equal 0. And then 2y minus 7 has to equal 0. So now if I'm solving each of these, on the left one here, I have to subtract 7 on both sides. That gives me 2y equals negative 7. And then I have to divide by 2 on both sides to get y equals negative 7 over 2. And that's my first solution. On my right branch, very similar, except that I have to add 7 on both sides first. That gives me 2y equals positive 7. So when I divide by 2 on both sides, I get y equals positive 7 halves, 7 over 2. Okay. Number 4 is a little bit tricky because it's set up not as two parentheses. It's given to us as a parentheses squared. So what I have to remember for that, just like we had on the puzzle time for 7.3, where we started trying to go through and FOIL those or multiply those out when they were perfect squares, when they had squares here. This is the same thing as z minus 1 times z minus 1 equals 0. So I'm going to go ahead and set each of those equal to 0. Z minus 1 equals 0. Z minus 1 equals 0. You can see pretty quickly here, though, that even though I have two separate equations, I'm going to get positive 1 for the solution for both of them. If that is the case, you don't necessarily have to list them twice. You can just list it once. Z equals 1 is my only possible solution. This is something we'll see more so in Algebra 2. It's not really an Algebra 1 idea. But here, positive 1 is what we would call a repeated solution. That phrase we'll use. If you want to get really fancy with it, this is an Algebra 2 term. It has a multiplicity. That's a fancy word. Multiplicity of 2, because I have that as a solution 2 times. Multiple times, but specifically 2. But again, for our intents and purposes, this just saying that z equals 1 is my only solution is totally fine. That's all you guys would need to know for that section. All right, last one, box 4, are really challenging ones, which I just am now realizing that it's already printed out for you. It's already uploaded on Google Classroom, and I'm obviously looking at it here. I took this 4-box notes from an Algebra 2 thing and totally forgot to change the title of this box here, Graphing Logs. This should be extreme or advanced, expert, whatever level questions. It's our most difficult ones. But once again, you can see the problems themselves structurally are still going to be exactly the same. It's just that the only thing that I can do to make it more complicated is add more terms to it. If I have 3 things multiplying together to get 0, I still need to have at least one of them be 0 in order for it to be true. So we're just going to do the same thing. I'm still just going to set my parentheses equal to 0. So here m plus 1 equals 0 is option 1. M minus 3 equals 0, option 2. And then m minus 2 equals 0 is option 3. Those are my 3 different parentheses. If I can get any of those equal to 0, then I'll have a solution to my equation. So subtracting 1 gives me m equals negative 1 for my first one. Adding 3 on both sides gives me m equals positive 3. And adding 2 on both sides gives me m equals positive 2. So those are my 3 solutions. Either negative 1, positive 3, or positive 2 will give me a 0 for one of my 3 parentheses. Last but not least, number 6, we've got 4g times g minus 3 times 2g plus 5. Same thing. I'm still just going to set each of my parentheses equal to 0. 4g equals 0. G minus 3 equals 0. And then 2g plus 5 equals 0. So in kind of factor number 1, I've got to divide by 4 on both sides. We get g equals 0, because 0 divided by 4 is still 0. Factor number 2, add 3 on both sides. G equals positive 3. And then factor number 3, that's going to be our hardest one here. We've got to subtract 5 on both sides. That gives me 2g equals negative 5. And then I have to divide by 2 on both sides. That gives me g equals negative 5 over 2, which is negative 2.5. So those are my 3 solutions, 0, 3, and negative 2.5, or negative 5 over 2. And that's pretty much it. So, like I said, even though the individual parentheses or the individual equations that you were solving got a little more complicated, or maybe there's more of them, but it's really the same process over and over again. Once they are factored out, which is what we're going to be starting with for all of these, you just set each parenthesis equal to 0 and solve. The individual problems should not be overly difficult for us. All right, so your homework is up there on the screen, page 381. Numbers 4 through 20, just the evens. As always, if you guys have any questions, concerns, thoughts, ideas, hopes, or dreams, make sure you guys are reaching out and letting me know. Otherwise, have a fantastic day. We'll see you soon.